Okay, folks, this is lesson 13, and we're going to learn about piecewise functions in this lesson. And piecewise functions, when you first see them, can be very intimidating looking because you don't know what to do with them, but they're actually very easy. I sometimes call them Frankenstein functions because all it is it's a function that is made up of pieces of functions, okay? And let me try to explain. What you're looking at here is a piecewise function. It's a pretty simple one. It only has two pieces. They can have an infinite number of pieces. You can have a piecewise function that has 1,000 pieces, but I'm not going to give you anything like that in this class. This has two pieces. This is one piece, and this is the second piece. But just as an example, you could have a function, let's say we had g of x, and every single line will be a new piece. So you can have a piece here, so you could have like, x plus 7 whenever x is less than or equal to negative 40. And then you could have, the next piece could be like 2, a constant function. And that would be when x is between negative 40 and let's say negative 20. And then you could have a third piece that is a quadratic, like x squared plus 16, and that can run from negative 20 up to, let's say, 0. And then let's say you have a piece that's like e to the x power, which we won't talk about right now. And let's say that doesn't even start up until you get to 7. And let's say that can go up to 12. So, this one has 4 pieces, but you can have 3 pieces. You can have 17 pieces. The only thing you can't have is you can't have only one piece. If it only has one piece, it's not a piecewise function. Okay. So let me erase this. I don't want to intimidate you too much. But this is what piecewise functions are. And let me describe here. So this side is the function. So this piecewise function has two pieces, x plus 9 and negative 3x plus 38. And then you have the domain of each piece over here. So this basically just tells you which x values this piece is active for. So you're only going to do this piece, x plus 9, if x is less than or equal to 7. So if x is 7, you're going to put it in here. If x is 6 or 5 or 4 or 0 or negative 100, it's all going to go in here. But this piece, this negative 3x plus 38, you're going to use that piece if x is larger than 7, if x is greater than 7. So if x is 7.5, you're going to plug it in here. If x is 8, you're going to plug it in here. If x is 100, you're going to plug it in here. So one important thing about a piecewise function is you should never be able to plug a number into more than one piece. It can only go in this piece or it can go in this piece. And you know where to plug it in based on this over here. And what we're going to do is I'm going to show you how to identify output values given certain input values. So if you input 0, what will the output value be? If you input 10, or if you input 7, or if you input 8, what will the output of f of x be? And it'll depend on this domain. First, you take the number, so 0 is on this part of the domain, and so we would plug it in here. So f of 0 would be 0 plus 9. Let's go ahead and do that now. We're going to plug 0 in, plus 9, and we know 0 plus 9 is equal to 9. And so f of 0 is 9. Well, what about f of 10? Is 10 less than or equal to 7? No, 10 is greater than 7. So 10 would be plugged into this piece right here. And so f of 10 would be equal to negative 3 times 10 plus 38. And negative 3 times 10 is negative 30, plus 38 is 8. So f of 10 is 8. How about f of 7? This is always a tricky one. Look, they both say 7, right? But this one does not say equal to 7. This one says equal to 7. So when x is equal to 7, we put it in this piece. So it would be 7 plus 9, which is 16. And then what's f of 8? Well, 8 is greater than 7, so that's going to go into this piece here. So we would do negative 3 times 8 plus 38. And negative 3 times 8, that's negative 24. And negative 24 plus 38 is 14. Okay? And so the way you know how to do, how to evaluate the value of a piecewise function is you first select which piece it's going to go on based on the domain over here, okay? And then once you select the piece, you just plug it into that particular piece and you get an output value, okay? Now we're going to learn how to identify the domain and the range of a piecewise function, and then there's a very special quality about piecewise functions. We want to know whether they are continuous or not. We'll get to that in just a couple minutes. Let's start with the domain. Well, to identify the domain of a piecewise function, what you're going to do is you're going to identify the domain of each of the pieces. So we have two pieces. Let's call this piece 1, and let's call this piece 2. So piece 1 and piece 2. So first we want to know, well, what is the domain of piece 1? Well, the domain of piece 1 is all x values less than or equal to 7. So that's negative infinity up to 7 with a bracket because it's or equal to 7. What about the domain of piece 2? Okay, well, the domain of piece 2 is going to be, well, it's all x values larger than 7. So we're going to start at 7, but not including 7, and we're going to go up to infinity. And so then the domain of the whole function, the domain of f of x, is going to be both of these union together. It's going to be negative infinity up to 7, bracket, union 7 to infinity. But look, because there's no break here, look at this. This goes up to 7, and then this starts back up at 7 and goes to infinity. And so this means that there's no break at all, and so we can actually just say that the domain is negative infinity up to infinity. And so the domain of this function is negative infinity up to infinity. Okay? So you can plug any number into this piecewise function. There's not a single number that you cannot plug into this function. Pick any number and it can be plugged into this piecewise function. Now that's not always the case. Sometimes there are numbers that cannot be plugged in, but not for this one. Okay. All right, so what we're going to do here, now we're going to do the range. The range is a little more challenging. So let's see here. Okay, so to do the range, we're going to do the same thing. We're going to identify the range of each of the pieces. Okay, so how would we identify the range of piece 1? Okay, well, basically what you do is you plug in the edge of the function. Okay, so we're going to plug a 7 in, and it really depends on whether it's linear or quadratic or something else. Okay, linear functions have they don't have any tricks in their domain. They typically go from negative infinity to positive infinity, but in a piecewise function, they're going to stop wherever the domain stops. So one of the edges of the range is going to be whatever when we plug in 7. So if we plug in 7 here, 7 plus 9 is, well, we've already done that, f of 7 is 16, right? And so the range, we have a choice here, okay? It's either going to be, it's going to be one of two things. It's either going to be negative infinity, it's either going to be negative infinity up to 16, or it's going to be 16 up to infinity. And the way we can find that out is simply by plugging in something smaller than 7. For example, we plugged in 0 here, and when we plugged in 0, we got 9. Well, is 9 on this one, or is 9 on this one? It's on this one. Look, 9 is between negative infinity and 16, and therefore this is not the range. The range of our first piece is going to be negative infinity up to 16. Okay. All right. Now let's identify the range of the second piece. We're going to do the exact same thing. We're going to find out what the edge is first. Range 2, okay, is going to be, okay, well, let's plug the 7 in. If we were to plug 7 in here, we would get, well, negative 3 times 7 plus 38, okay? And negative 3 times 7 is negative 21 plus 38, and that's equal to 17, okay? So it's either going to be negative infinity up to 17, or it's going to be 17 up to infinity. It cannot be both of them. It can only be one of them. Well, let's go find something else that goes on this piece. Well, we have f of 10 here, and f of 10 is equal to 8. And is 8 on this piece, on negative infinity to 17, or is 8 between 17 and infinity? Well, 8 is smaller than 17, so it's going to be on this interval right here. So it can't be this one. Therefore, the range of the second piece is negative infinity up to 17. And so now all we have to do is overlap these two ranges. Basically, the way we overlap them, you can see that they both include negative infinity. This one goes up to 16, and this one goes up to 17. And so this range here is included in this range, and therefore the range of the second piece is the range of the whole function. Okay, so negative infinity up to 17. Okay, and that's how we identify the domain and range of a piecewise function. I think what we're going to do now is in the next video, I'm just going to do a bunch of examples of identifying the domain and the range. But let's real quick, let me explain what it means whether they're continuous. To find out whether it's continuous or not, what you're going to do is, I call that you're going to, well, step one, for it to be continuous, your domain has to go from negative infinity to positive infinity. If your domain does not go from negative infinity to positive infinity, then it is not continuous. But it does go from negative infinity to positive infinity. So there's two conditions to be continuous. All right. The first condition is domain. The domain must be negative infinity up to positive infinity. Okay. Now, there are exceptions to that in other kinds of functions, but in the realm of polynomial functions, where we are right now, this is our condition. The domain has to be negative infinity to positive infinity. The second condition is this, both pieces, let's call them pieces, both pieces, okay, must be equal. Must be equal at the transition value. Quote, transition. I call it the transition value. In this case, 7 is the transition value. 7 is the x value where we switch from this piece to this piece. At 7, we stop using this piece and we start using this piece. So 7 is the transition value. So what we're going to do is we're going to find out if both pieces are equal at the transition value. And the way you can find that is by plugging the number into the piece. So plug 7 in here, plug 7 in here. If you get the same number, it's continuous. If you don't get the same number, it's not continuous. So let's go ahead and do that real quick. Use a different color here. All right. So if we plug 7 in here, 7 plus 9 is 16. So the output value at the transition is 16. Plug 7 in here, and we get negative 3 times 7 is negative 21, plus 38 is 17. So the transition value is 17. And since 16 does not equal 17, this piecewise function is not continuous. I think maybe in the next video or the third video, we'll do a whole bunch of examples of identifying whether it's continuous or not.